Welcome to the deep dive. When you think Hawaii, you picture sunshine, right? Beaches, perfect weather.
Absolutely. Paradise.
But here's the thing, it's also incredibly wet, like feet of rain annually in some places, especially during their wet season.
Yeah, a real paradox.
So how do you make solar power work reliably when clouds are constant and it's pouring rain? That's the challenge Hawaii is tackling.
And it's leading to some really innovative thinking.
Exactly. So today we're digging into the source materials notes, reports to see how they're actually turning this challenge, the rain, into part of the solution for solar.
It's fascinating because Hawaii is already, a big player in solar. A huge chunk of their electricity comes from it.
Right. The sources mentioned they're one of the top states.
But that rain, like you said, it's not just a minor detail. It's a major factor they have to deal with.
And the rainfall numbers we saw in the notes are, well, pretty dramatic in certain spots, very concentrated sometimes.
Definitely. And it really does hit solar efficiency hard. The sources talk about production drops, sometimes 50%, even up to 80 or 90% on really bad rainy days.
Wow, 80, 90%?
Yeah, mostly the cloud cover, obviously blocking the sun, but also the water itself on the panels scatters the light.
Okay, so production just tanks when it's really coming down. But I saw a note about what happens after the rain stops. Something interesting there.
Ah, yes. There is a bit of a silver lining. That rain, once it's done, it actually cleans the dust and grime off the panels.
Like a free car wash?
Sort of, yeah. So you often see performance actually boost a bit right after a good rain compared to if it's been dry and dusty for ages.
Huh, that's neat. But that boost is after the fact. How are they tackling the efficiency drop during the rain, making the systems tougher?
Well, the first steps are physical.
Mhm.
Simple stuff, really, like installing panels at specific angles, steeper tilt so the water just runs right off, doesn't pool.
Makes sense.
And increasingly, they're using hydrophobic coatings on the glass. Think of it like Rain-X for solar
Yeah.
panels.
Ah, okay, so the water beads up and rolls off faster.
Exactly. Minimizes the time water is actually sitting on the surface, messing with the light.
Right. But here's where I thought it got really cool in the nights. It's not just about getting rid of the rain, it's about using it alongside solar, this hybrid idea.
Precisely. That's the shift in thinking. Seeing rain not just as a problem, but, maybe a resource too.
So how does that work?
The basic concept is pairing the solar panels, the PV systems, with rainwater catchment. So you're generating electricity when the sun's out, and you're collecting the rainwater that falls on the same roof or structure.
Dual benefit, energy and water.
Exactly, addressing both needs with one integrated setup.
And the sources had some great real-world examples, like in farming, Parker Ranch using solar to pump the rainwater they've collected for irrigation.
Yeah, and often with smart systems now, using tech, I think OneNote mentioned a specific controller, PIC16F877A, basically automating it, measuring soil moisture, only watering when needed, cuts waste way down.
And it's not just big ranches, right? It scales.
Oh, totally. Down to the community or even household level, you see lots of rural homes with rooftop solar feeding into batteries
Mm.
alongside big tanks, maybe 10,000 gallons or so collecting rainwater, enough for their needs year-round sometimes.
And commercially, I saw mentions of things like solar carports.
Right, like at the Wet and Wild Water Park. They have solar carports, but crucially paired with big battery storage Tesla Megapacks, I think.
Ah, so they squirt the solar power.
When the sun is strong, yeah. And then they can use that stored energy to keep things running smoothly, even when it gets cloudy or rainy, avoiding those dips. Provides backup, too.
So connecting this all up, what's driving this push? Is it just the weather, or are there bigger economic and policy things at play?
Oh, policy's huge. Hawaii's got that incredibly ambitious goal, 100% renewable energy by 2045.
Okay.
That mandates innovation.
Okay, that's a big target.
And economically, it made sense, too. For homeowners, the return on investment for solar, especially with battery storage now, is getting pretty compelling, helped by tax credits. And for the utility side, these huge projects, like the Kuhilani Solar Farm on Maui, they pair massive solar arrays with equally massive batteries. That buffers the whole intermittency issue from clouds, makes solar more reliable for the grid.
And didn't the notes mention something about homeowners getting paid to share power?
Yes, the grid service program. It basically incentivizes people with batteries to send power back to the grid during peak demand times, which often coincide with, say, evening cloud cover when solar output drops. Can mean real savings.
Okay, but let's be real. Those notes still mentioned heavy, persistent cloud cover causing massive efficiency drops. Sometimes, over 90% loss? Batteries can only do so much if there's no sun for days, right?
That's absolutely true. It remains a challenge. But the innovation is trying to tackle it from multiple angles. The batteries are key for bridging shorter gaps, soaking up excess power when it's sunny.
And the cleaning.
Robotic cleaners are becoming more common on larger installs. They keep panels operating at peak efficiency, which is critical if you're trying to maximize every bit of sunlight you do get. Plus, using better corrosion-resistant materials helps panels last longer in that humid, salty air.
Any really out there future tech mentioned?
Well, there's early research into things like hydrovoltaics, basically trying to generate tiny bits of power from the physical impact of raindrops hitting a surface. Still very experimental, but it shows where people are looking.
To kind of wrap this up with a specific case, Molokai seems like a great example.
It really is. It's community-focused, combining solar, battery storage, and that rainwater catchment for irrigation, specifically benefiting local farmers and households. They saw real reductions in water and energy costs.
So it's about building resilience at the local level.
Exactly. It's not just about green energy in isolation. It's about integrating systems energy, water, to make the whole community less vulnerable, especially thinking about climate change impacts.
So looking at Hawaii, it seems their unique climate, this mix of intense sun and heavy rain, really forced them to innovate in ways others maybe haven't had to yet.
Definitely.
They're showing how you can take what looks like a disadvantage, the rain, and actually integrate it, find opportunity within the challenge, leading to more sustainable, resilient systems.
And it really makes you think, doesn't it?
Yeah.
If sunshine and rain, seemingly opposites, can be combined like this for energy and water, what other contradictory elements in our environments could we potentially harness together? What other unexpected pairings could help us build resilience and meet future needs?